All right, key topic 13, VHF equipment controls. Where are we going? All right, I'm showing a little bit of equipment here. This is some of the requirements. This might be a good point to take a look at the regulation a little deeper. All right, that's going to be found in subpart W of part 80. Contains the rules applicable to the GMDSS. Every ship of the U.S. subject to the Communications Act or the Safety Convention must comply with the provisions of this subpart. And here you will see that some of the requirements are listed, like VHF, the transmitter and the receiver, and the power and the antenna. So that's what this section is going to be quizzing us about. So if we just quickly go through the regulation, you'll see that this subpart is applicable to all compulsory ships unless they have some sort of exemption. They define what the station is, where it should be. We looked at it. It's got to be in an adjacent room. The installation, basically, it's got to include an antenna, a source of energy, a transmitter, and a receiver. The transmitter must have certain requirements, and the receiver must have certain requirements. The main power supply has to maintain a certain level. There has to be a reserve power supply. The battery or other power capacity, reserve power, so I guess it is battery, must be able to function for, 6 hours? You must be able to prove that you meet those requirements. The antenna, emergency electric lights, a clock, spare antenna, tools, instruction books, etc. should be on board, along with any type of cards or placards. You're subject to a test. And here we're getting into the VHF requirements, where it should be, how it should be installed to avoid vibration and moisture. A repeat, the VHF radio must have a transmitter, receiver, a power supply, and an antenna. Otherwise, I don't think it's going to work without any of the above. Well, I suppose it could work without a transmitter. It's just you can't transmit. We're getting into some of the questions that we're going to actually be covering here. The requirements of the transmitter. I think the first regulation we looked at before I flipped over was C. The transmitter must deliver a carrier power between 8 and 25 watts into a 50 ohm effective resistance, and you must be able to reduce the power to a value of 1 watt or below. The receiver, the power supply, and these are the specific requirements if you're a compulsory ship. The antenna, it must operate. And I think that might pretty much wrap up. I think it went to 882. There it is. All right, I think that's it for that subsection. Yes, it is. So let me go ahead and I'll minimize that. We'll come back to what we're talking about. Yes, that one I read to you has to do with the VHF radio telephone transmitter, and it must have power enough to send out up to 25 watts with a 50 ohm resistance. Usually the resistance is what's built into the transmission line or the antenna. While we're in the classroom, we should probably find the radios that we can use and actually manipulate the controls a little bit so that you're a little more familiar with them. I don't know whether I should go into what some of these soft keys actually are, what their function is. You can see latitude and longitude and minutes, seconds even, is shown on the screen. It looks like there's also a time, the channel that you're on. Here it says busy. Down the road we're going to see the USA as opposed to international. You can see it's operating at 25 watts. Maybe you can't, depending on your screen. Let's go ahead and take a look at what the question says. All right. VHF ships, transmitters, station transmitters, must have the capability of reducing carrier power to was that 1 watt, 10 watt, 25 watts, or 50 watts? Now this one here, what must you have the capability of reducing the carrier power to? And I believe it was 0.1 to 1 watt. So I see pretty much everybody answered. So it's going to be the 1 watt. And if I go back a screen, provision must be made for reducing carrier power to 0.1 to 1 watt. Yeah, 25 watts is usually the high end of what you transmit at. So if you're going to reduce, the only two reductions are going to be 1 or 10. So 1, if you'll recall, if you're in the bridge-to-bridge communications where it's navigation maybe in channels where the ship is pretty much next to you, you don't need to be broadcasting to the other side of the state. If you're just talking to one of the ships that is waiting to enter the Port Everglades. So 1 watt is correct. Because it's usually within eye shot, and 1 watt is more than powerful enough. If the station does not respond, then try calling with a higher power. And I wouldn't go right to 25, maybe 5 or 10. In telecommunications, squelch is a circuit function that acts to suppress the audio output of a receiver in the absence of a strong input signal. Essentially, squelch is a specialized type of noise gate designed to suppress weak signals. And they're showing the threshold here. So in the dark green, you're getting a little bit of a signal, but it's not really strong enough. So it must not be that close, or it must not be at that higher of power. But if your squelch is set to that level, you're not going to hear anything. It's going to still be a quiet radio until you hear the louder or more powerful message. If you have the squelch on, in effect, 0, you're going to hear all the static. And the illustrations on the bottom also show how don't have it turned up too high, otherwise you're not even going to get the strong signal that's close to you. There is a squelch button attached. Basically, the trick is to turn it until you no longer hear the steady interference. And maybe just a touch more. And here's a question on squelch. Which of the following statements best describes the correct setting for manual adjustment of the squelch control? So the best statement we're looking for. A, adjust the squelch control to the minimum level necessary to barely suppress any background noise. B, always adjust squelch control to its maximum level. C, always adjust squelch control to its minimum level. Or D, adjust squelch control to approximately twice the minimum level necessary to barely suppress any background noise. All right, so the twice is not going to be the correct answer. I'd have to read these a little closer because A looks good, adjust squelch control to the minimum level necessary to barely suppress any background noise. Again, they don't write these the best. B, always adjust. Well, always adjust to the maximum. No, because then you're not going to hear anybody then. The minimum. Okay, now that I'm going through it a little bit more, the minimum you're going to hear everything, including all the interference that you don't want to hear. This is a conclusion I'm making. I might be wrong. I do like the barely suppress any background noise to the minimum level, so you're not going all the way to the total minimum. You're going to the minimum level where you're just barely suppressing it. So I'm talking myself into A is the best answer. It is. After missing a couple, I'm a little gun shy here. Apparently, this is a logical question. And after slowing down a little bit and reading it, yes, we did use some logic to answer it. If you turn it any further, you might squelch out a weak distance signal. So do not do it to maximum. Share the results. Not bad. Scanning. Scanning is a way in which the radio can be configured to monitor and receive more than one channel or group of users. It's a very simple system. It's largely outmoded by digital radio. The radio will have a button or a scan control, which when set will cause the radio to sequentially listen to each channel on the scan list. The scan lists are the channels or the group of users that you wish to monitor. The scan list is usually pre-programmed into the radio at the time the radios are initially configured. When scanning, the radio briefly listens to each channel in turn. If it hears no activity, it moves on to the next channel in the scan list. It does this very quickly, monitoring several channels per second, reaching the end of the list, returning to the first channel, and so on. So it's basically just running through all the channels. If it hears anything, it'll stop on that channel. And it opens the speakers so that the user can hear the call on that channel. I see the picture. Somebody's hitting the distress button, but there is a scan button here right under channel 16, shortcut key. I imagine that's what that is. All right, so question on the scan function. It's used to... So what is the scan function used for? Is it A, monitor channel 16 continuously and switching to either channel 70 or channel 13 every 5 seconds? No. B, scan channel 16 for distress calls. C, scan channel 70 for distress alerts. Or D, sequentially scan all or the selected channels. All right, very good. That's going to be our correct answer there. So you don't have to actually keep pushing in the buttons. You wouldn't want to do that after a minute or so anyway. So it's pre-programmed into the radio. You've got a list of 10 channels. 6 of them are distress. 2 others are for your own safety or navigation. And it'll continuously scan through those for you. So that way you don't really miss anything. Dual watch, or sometimes even tri-watch. It's a feature on the Marine VHF to monitor the reception of multiple channels together automatically. Dual watch and dual standby are the same thing. It flips back and forth between the A and B channels quickly until one breaks the squelch. You can use any combination of UHF and VHF. So it's not quite scan, but it's you can watch dual watch two. You can listen to 2 stations, or tri watch 3 different frequencies. Which I think the DW is going to be dual watch on the soft keys. All right, the dual watch function is used to A, listen to channel 70 at the same time while monitoring channel 16. B, sequentially monitor 4 different channels. C, sequentially monitoring all VHF channels. Or D, listen on any selected channel while periodically monitoring channel 16. So far, I kind of like that because it's got the two channels, and 16 is the other one that you want to listen to. However, A kind of says the same thing. The only thing is channel 70 is more the digital. That's the DSC, the digital selective calling. So you're not going to really be listening to that channel. So I like D the best. I certainly don't like B because it says 4. In dual, the word itself is 2. Or sequentially monitoring all the VHF channels. Well, that would also include what? The FM broadcast channels? That's a little too broad. I better listen to some of the top 10 radio stations in addition to the maritime stations. So, no. So, between A and D, I guess I'm going to go with D. And it is. So, basically, it's an older thing. It allows the radio to periodically sample channel 16 for activity. All right, simplex and duplex. You're going to see that also. Basically, simplex is probably what you're most familiar with. You're both on the same channel. You're listening and they're talking. You can't necessarily do that at the same time. Your radio usually has a, your receiver has a little switching mechanism that will basically listen and then transmit, listen and transmit. It usually doesn't do both at the same time. With duplex, you can, in effect, do both at the same time because you're basically listening and transmitting on 2 different frequencies. The frequencies are very close to each other, but it does allow you to, in effect, talk over each other. Although in the illustration, they are doing the same thing. There's transmissions and receiving during the same time period. So duplex means that a radio station transmits on one frequency and receives on a different frequency. That does become important when it comes to international versus USA. So have you ever wondered what that control on your radio means? One that says USA or INT. So it's either here or international. What happens is that the USA uses far less duplex channels. So if you and your mate at the island, Anchorage, both had your radios adjusted to the USA option, you could talk to each other on more channels directly. To put it simply, simplex frequencies are boat to boat. Duplex frequencies are boat to repeater to boat, even if the boats are next to each other. I don't know if that makes a lot of sense to everybody. You can see that duplex is used internationally more frequently as opposed to USA, where it's mostly simplex and just a few duplex channels. And there is a Canadian, in the illustration you can see there's a third one to actually go to Canadian. So press and hold for 2 minutes to change the channel modes from USA to Canadian to international. The modern marine VHF transceiver automatically selects simplex when the radio indicates domestic or the USA mode on these following channels. So it's all programmed right into the radio. If you select, in this case, let's say you select channel 7, it's going to automatically switch you over to simplex if you have the dial turned to USA. What is the purpose of the INT-USA control settings on a VHF? All right, so what are the purposes of that little control button? Is it A, to change all VTS frequencies to duplex? That's the vessel traffic service. So that all vessels can receive maneuvering orders? Is that the purpose of that button? It may be one of the side purposes, but it's not going to be the dominant purpose. B, to change all VHF channels from duplex to simplex while in U.S. waters? Let's see if there's a better answer. There probably is. C, to change certain international duplex channel assignments to simplex in the U.S. for VTS and other purposes. Or D, to change to NOAA weather channels and receive weather broadcasts while in the U.S. Oceanic and Atmosphere Authority. That's, basically, it's a government department that has to do with weather. And it's not the National Weather Service. All right, but I don't believe that that's the purpose of it. All right, so this one here, I don't really have a strong preference for one or the other. All right, so INT or USA, I would eliminate the VTS to change VHF channels from duplex to simplex while in U.S. waters, and I don't, like I said, I'd rather have a better answer. Or C, to change certain international duplex channels to simplex in the U.S. for VTS and other purposes. All right, I do like that one. It's broad enough and it covers that other. So instead of changing all the channels from duplex to simplex, it just changes certain channels. So see, yes. Some VHF channels have dual roles throughout the world. For instance, channel 7A is for simplex communications here in North America. However, in other parts of the world, channel 7 with no A after it splits the receiver 4.6 megahertz up for duplex operation, receiving at 160.950. For operation here in North America, always make sure the VHF radio is in the USA domestic mode. All right, fine job. And the poll. Share and stop share. All right, this one here, I'm not explaining before I answer the question, so it's basically going to be similar. All right, we are talking about simplex here. So why must all VHF distress, urgency, and safety communications, as well as the VTS traffic calls, be performed in simplex operating mode? So why should they be in simplex? Is it A, to minimize interference from vessels engaged in routine communications? So is simplex going to interfere with other vessels? That's not exactly what they're asking about. 2, or B, to ensure that vessels not directly participating in the communications can hear both sides of the radio exchange. C, to enable an RCC or coast station to only hear communications from the vessel actually in distress. Or D, to allow an RCC or coast station to determine which transmissions are from other vessels and which transmissions are from the vessel actually in distress. All right, that's quite a question there. I don't think I noticed it ahead of time, so I didn't prepare it that well. But let's see if we can logically come to the answer. I see so far we don't have consensus in the poll. So why should the DUS calls be in simplex? Well, I wouldn't worry about interference. I would want more people to be able to hear it, so B does sound decent. C doesn't. I don't really like it because it's got the only word, but I've also learned not to take extra words at their face value. But the coast station only wanting to hear from the vessel actually in distress, as opposed to maybe somebody that is approaching the vessel for rescue purposes. So I don't like the only word, so I'm going to eliminate that as a possibility. Or D, to allow the coast station to determine which transmissions are from other vessels. I don't know. I guess out of all of them, probably the best answer, I do like B then. We want more people to actually hear it. We'll see. I could be wrong on this one. All right. I guess the logic did come through, and the majority of the poll takers got the same result. I'll share that now. Stop sharing. So if the VHF transceiver inadvertently gets switched to the INT mode, the receiver offsets, blah, blah, blah. This is a big problem with the U.S. Coast Guard on simplex liaison. All right. I'm not sure whether that's going to be extra language that we don't really have to worry about. So basically, go through the steps that we did. Eliminate the ones that do not seem to have anything to do with it, and then closely look at the couple that are left. All right, that's going to be it for that one.